Okay, so in this session, we continue our discussion on the divisibility tests, and we'll be discussing about divisibility tests for number 9 and 11 in this session. In order to do that, let us find out some numbers, some 2, 3 and 4 digit multiples of 9. So I have already done them here just so that we can move on faster. So the 2 digit multiples which I have obtained by multiplying 9 by 2, 3, 4 and so on are 18, 27, 36 and so on. This list can go on further. Then we have the 3 digit multiples starting from 108, 17, 126, 135, 144, 153, 162 and so on. And then we have this 4 digit multiples is 4059, 4068, 4077, 4086 and so on. Now again, what we try to do is to see if there is anything common in these multiples of 9. Can we see some patterns? So it's difficult for us to figure out if there is any pattern here. So we try something which we did for divisibility test for the number 3. What we did is we tried adding the digits. So now what we'll do is we'll add all these digits, 2 digits, and we'll add the digits in this multiple. So we'll add 1 and 8. Now let us try to do the digits of adding the digits of these multiples for all of these. So for the 2, I'm just writing 1 plus 8 is 9, 2 plus 7 is 9, 3 plus 6 is 9, 36, 45 when I add it is 9, 54 when I add again it is 9, 63 when I add is 9, 72 when I add is 9, okay, when I add 81 again it is 9, 90, 9 plus 0 is 9, okay, 99, 9 plus 9 is 18. So that is what we have written. How about the 3 digit multiples? So let us try writing the sum of digits for the 3 digits multiples. 108, if we add them it's 9, 117 when we add is 9, 126 is 9, 135 when we add the digits it comes out to be 9, again 144 is 9, then 153 is again 9, 162 is again 9, and we could go on further. Now let us try to add the 4 digit multiples. So 4 plus 5 9 and 9 is 18. Similarly, if we add 4 plus 6 10 and 8 is 18. Then we have 4 plus 8 12 plus 6 again it is 18. Okay, 4 plus 5 9 and 9 is again 18. So what you can see now, can you see a pattern over here? Well, the pattern is very obvious that if the sum of the digits of a number is a multiple of 9, or in other words, if it is divisible by 9 straightforward, then we say that the number is divisible by 9. Right? And just to let you know that there is only one number which is a 1 digit multiple which will be multiple of 9, that is 9 itself. So having said that, now let us go and discuss the divisibility by 11. So this one is a little bit different here, and we have to use a different approach to find out whether a number is divisible by 11 or not. So what we are going to do here is, I have taken 3 numbers. I have made a table here just for the sake of convenience, and we have taken 3 numbers, 319, 1342 and 61,809. Now we have to use a method. So first what we need to do is we need to find out the sum of the digits at odd places starting from right. So this is the right. So we have this number 9 here. The other odd is the number 3. So that is 1, 2 and 3rd. So we add 9 plus 3. So this gives us 12. Then it says sum of digits at even places from right. So this one is the odd place, this is the even place. We have 1 and that's the only one we have. So it is just 1. Now what is the difference of these? 12 minus 1. The difference of these 12 minus 1 is 11. Now let us try to do the same thing for this another number 1342. So first I add the digits at odd places starting from right. So number 2 and number 3. Number 2 and number 3. So 2 plus 3 equals 5, and then we add the digits at even places. So in this case we have 4 and 1, that is 5. 4 plus 1 equals 5. Now we take the difference of these two sums, that is 5 minus 5, it gives me 0. Now let us try to do this for the third number, which is 61,809. Now first we have to add the digits at the odd places. So it is 9 added with 8 added with 6. So we do 9 plus 8 plus 6. So 9 and 8 is 17, and 17 added with 6, it gives you 23. And then we can add the number at the even places, that is 0 and 1. So we have 0 plus 1 equals 1, and then we take the difference of these, that is 23 minus 1 equals 22. Now do we see a pattern over here? So we have, when I take the differences, I see 11, 0 and 22. So 11 and 22 are clear multiples of 11, right? So this is the method that we use here, right? And if we would like to summarize the method, it would be, first we find the difference between the sum of the digits at odd places starting from the right. Then we find the sum of the digits at even places from the right of the number, okay? And then we have a look at the difference. Now if the difference is either 0 or divisible by 11, then we say that the number is divisible by 11. So in this case, all these three numbers, 319, 1342 and 61,809, all these numbers are divisible by 11 because it satisfies our criteria of the difference being either a divisible by 11 or 0. Hence all these three numbers are divisible by 11. So that was our discussion on divisibility tests for the numbers 9 and 11. See you soon in the next session.